In this video, we're going to derive the kinematic equations. We're going to use the SUVAT variables in this video. I got a request to do this, so I'm going to do this. This is different from the previous one because this one is using the SUVAT variables. So just to define what each of these variables are, we have S for displacement, U for initial velocity, V for final velocity, A for acceleration, and T for time. So I'm going to start off with a graph, and this is going to be a velocity versus time graph. And this object here is accelerating, and so these equations that we're going to derive assume constant acceleration. Okay. So the initial velocity is going to be U, and then the final velocity is going to be V. And I'm going to start with the definition of acceleration. So acceleration is the change in velocity divided by the time. And the change in velocity is V minus U, final velocity minus initial velocity, divided by the time. I'm going to multiply T on both sides, so I get AT equals V minus U. And then if I solve for V, V is equal to U plus AT. And that's our first kinematic equation. Okay. Next, we're going to use this graph to derive our next equation. We know that the area under a velocity versus time graph is the displacement. So this is displacement, this is displacement. This looks like a rectangle, so I'm just going to take the U times the T. And then this looks like a triangle, so it's going to be 1/2 base times height. So 1/2, and the height is V minus U, and then times T. Okay. So now I have the displacement is equal to, I'm going to add up that area, which is UT plus 1/2 times V minus U times T. Now, this V minus U looks familiar. We've seen this before, which is from up here. So we're going to substitute that in here. So we have S equals UT plus 1/2, and V minus U, I'm going to substitute AT. So substitute AT here, and then I have T here as well. And then so we're going to square that. The displacement is equal to UT plus 1/2 AT squared. Okay, so this is our second kinematic equation right here. Okay. And then for our third kinematic equation, we're going to think about this idea of average velocity. So average velocity, you might see it written like this, sometimes it's got a bar above it, is equal to the displacement divided by the time. Okay, so that's kind of the definition of average velocity. Now, you can also find average velocity if it is constant acceleration. We can add the initial velocity plus the final velocity divided by 2. It's kind of like doing a simple average of two numbers. But this is true if the acceleration is constant, and this is equal to S over T. S over T. Okay. And then if we solve for S, we get 1/2 times U plus V, and then multiply T on both sides, and then we get T over here. Okay. And this gives us our third kinematic equation. Next, we're going to substitute from up here, from this one right here. We're going to substitute from this one right here. We're going to rewrite this. And then we're going to solve it for T, because we're going to use this in a substitution in a moment here. So I'm going to divide A on both sides. So I get V minus U divided by A. So T is equal to final velocity minus initial divided by the acceleration. And now I'm going to combine that with this equation right here. Okay. We're going to take those and we're going to combine it. And now we have the displacement is equal to 1/2 times, and I'm going to just flip the U and V. It's just going to, instead of U plus V, I'm going to do V plus u times, and then the t right here, I'm substitute it with this right here, v minus u divided by a. Okay. So I'm going to factor out the a right here so that it becomes 1 over 2a, and then we're going to multiply, do a little FOIL here. So we're going to get v squared minus vu, plus vu, actually minus vu, and then plus vu, and then it's going to be minus u squared. Okay, so it's kind of messy, but what we noticed here is that the VUs cancel out, right? So the VUs cancel out, and then we're going to get the displacement is equal to 1 over 2a, and then we have v squared minus u squared. Okay, and then I'm going to multiply the 2a on both sides to get rid of the denominator. So I get 2as is equal to v squared minus u squared. And then we'll get our fourth kinematic equation here. If we solve for v squared, it's equal to u squared plus 2as, and that is your fourth kinematic equation.